So molar concentration of 10 milligrams, what is it, 10 milligrams per milliliter BSA solution. That was the solution that you used. And the relative molecular mass of BSA is 66,000. So we know it's 66,000. And here it's the relative molecular mass, which basically what we do in this case is we just simply add a gram per mole. Okay? So I give you a couple of minutes to try and discuss that amongst yourself. How would you address this problem? I guess quite a number of you already have done that. But have a look at it, talk to each other, show each other how you would actually solve this question. Okay? Does that make sense? Yeah? And the rest, that is something for the biochemical pedestrians to put that into numbers. I'm pretty sure you can do that. Yeah? Not terribly challenging. I would expect you to be able to do that in about less than, say, 2 minutes, if it comes to a test. Right? Any questions about that? Of course, you can do it in a different way if you are so inclined. As long as you get the right result and the right unit, up to you. Okay? Right. Question number 2. What was that? Can't remember. Aha. How many moles of BSA? So how many moles? Of BSA, of the 10 milligram per milliliter BSA are in 3 milliliter. So how many moles are there? Okay. Sorry?
Isn't it 1 milligram over a milliliter in the question?
Is it 1 mil? You are absolutely right. I should never make assumptions. Totally right. Okay. 3 minutes? Keep talking. Show how you do it. So, what do we do in this case? What's the unit that we are looking for? Moles. And I do that. Do I do that? Maybe I don't do that. Okay, do we have any moles? Yep. So I have the moles come from this part here. 1 mole. What's downstairs? 66,000 gram. Do I have grams anywhere? Yeah? I can write this again as my 1 gram per liter by just simply cancelling out the m's. Let's do it that way. Okay? So, mole is in the right place. My grams cancel out. What's in the way? It's the liters, these guys here. Do I have anywhere something with liters? I have 3 milliliter, so that I can write as 3 times 10 to the minus 3, that's the milliliter. And what happens to the liters? They go as well, and all I am left with is basically 3 times 10 to the minus 3 divided by 66,000. All the units cancel out apart from the mole. And again, that's something for the biochemical pedestrians to hack that into your calculator. Yeah, shouldn't be too big a problem. Is that what you got as the answer? Equals 4 point, what was it? 10 to the minus 8 mole. Is he right? Yes. Ah, damn it. It's never a good sign if somebody is right. Excellent. So, again, this is a question I would expect you to do in about 2 minutes. Can you do that? In an exam? In a test? By the way the tests are going to work is, obviously you're doing your quizzes as practice. And these quizzes count towards your mark for this module. Yeah? If you get less than 80%, you haven't passed it, the quiz, and you will get 0 for it at Judgment Day. Judgment Day is the 4th of May. Star Wars fans know the significance of this date. May the 4th be with you. Thank you, thank you. And so if you get less than 80% in the test, this test will score 0 for you. And everything that is 80% and above will score as the mark that you get for that. Yeah? So if you have one test, 100%, this will score 100%. If you have one test, 85%, that will score 85. If you have one test, 79%, this will score 0. Yep, life is tough. Life is a bitch. Okay? So this is coursework mark. Your coursework mark also is made up of an assessed practical. I think this is either in week 7 or 8. I haven't checked with the admin office. And where it is basically you have to perform a task in the lab. You have to measure something. And you have to do a very short write-up, show a graph and do a few calculations in the lab. So this will contribute to your coursework mark. But we will go through that first. This practical is very, very gentle again, so don't panic. And the third component of this coursework mark for this module is a test. I think it is sometime next term. It is a problem-solving test. It's a little bit like an exam. You have to do it individually, of course, like all the tests. And it's about an hour or so. The good thing is it's open book. Yeah, because I'm not a huge fan of memorizing things. So it is open book. You can bring along whatever you want. The only thing that you can't do is phone a friend. Yeah? And I would suggest also that you don't use the internet, because there's no point in really doing that. I announced that last year again in the test, and 5 minutes in, you could hear Siri saying, sorry, I didn't get that. So that is the coursework mark for this module, and it's made up of all these 3 components: the quizzes, the open book test, and the practical. The practical counts for 30%. The open book test count for 20%, and all the quizzes together also count for 20%. So that's that. And if you count it with me, there are still 30% left, and that will be an exam in the summer. It's a 2-hour exam. This exam has 30 multiple choice questions. And guess where these multiple choice questions will come from? From the quizzes, right? Well, perhaps not exactly the same numbers, but the same procedures, right? So 30 multiple choice questions, and I will give you 3 problem-solving questions, and you need to choose one of them. Yeah? So if you don't like statistics, I'm afraid there's no way out for you, because all 3 questions will contain a statistics element. Right? Okay, are you clear about how this thing will be assessed? Happy with that? Well, you don't have any other options. Okay, let's go to question number 3. What is the percentage concentration of the 10 milligram per milliliter BSA solution? And it is still 66,000 gram per mole. And the percentage concentration would be in weight per volume. Want to do that quickly? This is a question that you should be able to do in less than a minute. Talk to each other. Show each other how you would approach that problem. Yeah? Got it? So, what do we want? Breakfast. What do we want? We want percentage concentration. What is the definition of percentage? We want gram per 100 milliliter. Yeah? That is the definition of percentage. Now, what have we got? We have 10 milligrams per milliliter. But what we actually want is 100 milliliters. So all we need to do is we extend this fraction by 100. It's just simply extending a fraction. So at the bottom we have 100 milliliter. That's exactly what we want. And at the top we have 10 milligram times 100. So 10 times 100 equals 1,000. So we have 1,000 times 10 to the minus 3 gram per 100 milliliter. The 1,000 at the minus 3 cancel each other out. So all I have left is 1 gram per 100 milliliter. And that is exactly 1% weight per volume. That was really the long way for that. Are you happy with that? You could argue, hey, master, what about the 66,000 gram per mole? What do we do with that? What do we do with that? Yeah? Nothing. Sometimes I will give you too much information. Why? Loud? To confuse you, exactly. Yeah, because I'm a mean person. No, it's not to confuse you. I just give you that because I want to see whether you can select the right information. Right? Okay, that was question number easy. Okay, next one is determine the volume of 200 micromolar BSA. So you have 200 micromolar BSA, bless you, required to make up 5 milliliter of 25 micromolar solution. So actually, what have we got? Oh, why should I talk? Here's a solution. Say loud.
C1V1 equals C2V2.
C1V1 equals C2V2. Okay, over to you guys. Got something for that? Pretty straightforward. C1V1 equals C2V2. Or think about the guy coming into the pharmacy with a prescription, and the prescription says, give that poor sot 5 milliliter of a 25 micromolar solution. Yeah? And the pharmacist says, the hot pharmacist says, sorry, we only have 200 micromolar. Yeah? So what do we do? Well, basically, it's already written here. This here is the desk. So we have 5 milliliter times 25 micromolar. Here's the desk, divided by 200 micromolar. Micromolar cancels out. And we have 50 divided by 200 milliliter. What does that give? You are absolutely right. At least somebody is awake. 125 divided by 200 equals, what did you get? 0.625 milliliter, or that would be 625 microliter. Yeah? Happy with that? Did you get that? Yeah. Hey, you are turning into pros. I like that. Any questions? Excellent. Now, the last question, question number 5. That was a little bit interesting. What is the concentration of a solution made up by mixing 3 milliliter of a 10 micromolar solution, 10 micromolar solution, with 1 milliliter of a 30 micromolar solution? What's the concentration? This is truly a bugger. Do you want to try that yourself first? Give it a go. See if you can come up with a strategy for that. Have you got a strategy? What are we looking for? We are looking for concentration, right? So we are looking for a concentration. That's the first important thing. What is a concentration? Loud? Moles over volume. So amount over volume. Amount over volume. Excellent. Do we now know what our volume is? What's the volume? 4. Why? I mix 3 milliliters plus 1 milliliter. So the volume is 4 milliliter. Yeah? Make sense? 4 milliliters? So we have our volume. Now what is an amount? How do I measure an amount? Moles, exactly. So what I need to do is I need to calculate how many moles I have in solution A and how many moles do I have in solution B, and add them together. Yeah, make sense? So we are looking for moles. Try to do that in different colors, but they don't come out very well. So let's look for solution A. We are looking for mole. Do we have mole anywhere? Where? 10 micromolar. So I have 10 micromole per liter. That's this guy here. Yeah? And the mole here is okay. What do I do with the liters? Times 3 times 10 to the minus 3 liters, so the liters cancel out. Probably need to write it a little bit nicer with the micro. Micro stands for? So I have 10 times 10 to the minus 6 times 3 times 10 to the minus 3, bless you, mole. Okay? That's for my first solution. So that's 30 times 10 to the minus 9 mole. Is that right? Got that? Okay, so that was the first solution. Now for the second solution, I do exactly the same thing. Let's see if that looks better. So for the second solution, I have mole. I have a 30 micromolar solution. So 30 micromole per liter. The moles are all right. I now get rid of the liter, so that's 1 times 10 to the minus 3 liter. Liter cancel out. And I've got 30 times 10 to the minus 6 mole times 1 times 10 to the minus 3. And the unit is mole. And I get, again, 30 times 10 to the minus 9 mole. Yeah? Happy with that? So that is in my solution B. And if I put them together, A plus B, how many moles do I have? That gives me 30 plus 30 times 10 to the minus 9 mole. And that is 60 times 10 to the minus 9 mole. That's how many moles I have picked up from both solutions together. Yeah? So I have 60 times 10 to the minus 9 mole in both solutions. And what was the volume together? 4 times 10 to the minus 3 liter. Yeah? And I want the concentration, and we said concentration is mole per liter. So all I need to do now is 60 times 10 to the minus 9 divided by 4 times 10 to the minus 3. So that gives me 15 times 10 to the minus 6 mole per liter. Have I done that right? Yeah? Now, 10 to the minus 6 I can write in a slightly different form. What is 10 to the minus 6? 10 to the minus 6 is micro. So I can write this as 15 micromole per liter. And that's the same as 15 micromolar. Did you get that? Did you get that? Yeah? Yeah. Well done. Good man. Did you understand the concept? The concept is, go back to moles. If in doubt, go back to moles. See how many moles you have. That's always a good strategy. And also think about how much volume you have then. Any questions? Clear as mud, hey? In this case, I would suggest go in peace. And I see you in week 5. Oh my God. See you in week... Oh, I know. No, you don't see me next week.